Hello, my name is Mark Galpin. I'm the head of solutions architecture at Tidelift, and I'm here today to talk to you about the software supply chain. And you've probably heard a lot about software supply chains today, and if you haven't yet, there's plenty more that you can hear here at Upstream. And you might be asking yourself, why do we care? Well, the reason why we care is because it matters. I mean, it sounds like a simple thing to say, but this XKCD is not a new XKCD. But unfortunately, what it says remains true. Log4Shell, which happened this past December, is a reminder of something that we learned in Heartbleed and other times, that some of the most important libraries on the web are being maintained by people who are doing it for free and thanklessly. And it's an interesting question. What does a software supply chain mean? And the title of this talk says the state of the software supply chain. But in reality, I'm going to spend most of this talk just talking about what is a software supply chain and what does it mean to say we've got one. And I'm not alone in talking about a software supply chain, of course. But in recent times, it's gotten to be a much bigger thing. We're starting to see really big players start to not just talk about a software supply chain, but really start making commitments on how they can improve it, whether those people be major tech giants or the United States Congress. And one of the things that we talk about is how have things changed over the years, and this is a big change. Some people might say, oh, the software supply chain is just a buzzword. But when people are talking about 10 million, 30 million, there's a congressional hearing on C-SPAN, this has gone beyond just buzzwords and into actual work that people are doing. And that's a good thing. So I thought, if everybody's going to talk about a software supply chain, and I'm going to claim that it's something other than a buzzword, I should do some research into what a supply chain actually is. And so I went and I did some Googling about real world physical goods supply chains. And I ran across a number of articles that talked about what is a supply chain. And honestly, I'll tell you, I was expecting to get lots of things about, like this graphic I have on the left here, talking about raw materials and logistics and shipping and that sort of thing. And I did get a little bit of that, but actually when I asked what is a supply chain, what I actually got is these 5 points on the right, or some variants thereof, talking about planning, sourcing, inventory, production and transportation, and returns. And so I thought I'd walk you through those concepts as they relate to a software supply chain as opposed to a physical supply chain. And hopefully your eyes aren't glazing over at this point. One of the great things of this being virtual is that I can't tell. On the other hand, the downside is that I also can't hear you laugh at any jokes that I managed to land. So, we'll see how this goes. So let's start by talking about returns. And of course, probably the first thing if you're in the software industry when you hear about returns is, returns aren't really a thing in software anymore. I'm actually old enough to remember when software came on physical objects and you could, in theory, return those physical objects to the person that you bought them from. But for the most part, returning software is kind of hard to do. And it certainly does not, in the modern era, involve shipping anything. But in reality, when you look at the things that companies are talking about when they're talking about returns, they're not just talking about the physical supply chain of how do I ship an object back to the manufacturer. They're talking about the entire support process for software. And as head of solutions architecture at Tidelift, one of my responsibilities is support. And so absolutely, I can tell you that the software industry has this concept of customer support. And part of that concept is the concept of traceability. And I've decided to show you a barcode with a serial number on it. And I picked this particular one of a physical machine. Probably if you look at it, you can kind of guess what sort of machine it might be. And one of the things that I found was really interesting about this barcode is it doesn't just give me some obscure serial number, but it actually tells me here are a bunch of things that make up this machine. And it tells me these things because they're important if it ever comes to trying to figure out what might be wrong with this machine. And this is one of the key points that I think thinking about returns really tells you about, which is that if you don't know what the product is, you can't give good service. And you can't, for example, issue a recall. And one of the equivalents of a recall in the software industry is a security alert. And it's probably because of this that the White House, in their order on cybersecurity, which came out last May, ordered that the government and strongly recommended that businesses that work with the government or in general as good business practices maintain accurate and up-to-date provenance of software code or components. That if you are selling a piece of software, that you provide the purchaser with a software bill of materials, and that you ensure and attest the integrity and provenance of open source software used with any portion of a product. So basically, what the White House is saying, what the government is saying, is that you as a software provider have a responsibility to tell people what open source products you are using. And the primary reason they're saying this is because if there is a problem with those, they want people to be able to know that and understand what security vulnerabilities, for example, your product may contain inside it. And this is pretty reasonable. Software bills of materials are a thing that people that are kind of focused on open source supply chains and open source software security have been talking about for a while. But it's also something that I think in broader industry, a lot of people have been feeling like they've been kind of calling out in the desert, as it were. Even today, a year after this order, Tidelift's own recent survey indicated that only about 30% of open source software users that we surveyed were aware that the White House had issued an executive order that related to software bills of materials. But the fact that the government is issuing best practices on this is major forward progress. And, you know, just a couple of years ago, people were talking about, like, you know, the biggest question in software bills of materials was how to spell it. So we've made a lot of progress. And one of the things that we know is that if you are an organization using software bills of materials, you tend to be a lot more confident that your open source components are up to date, secure, and well maintained. Basically, that you know what's going. And this isn't a huge surprise, right? That people that know what they've got are more confident that what they've got is in good shape. It feels in some ways almost like a kind of obvious thing. but I do think it's important to point out just how important it is, right? That, 87% of people that use SBOMs have a decent amount of confidence in their software components. Before we get talking too much longer about software bills of materials, I also want to mention that software bills of materials are a turtles all the way down thing. Throughout any talk about a supply chain, you can always look at it from different levels. Just as an example, in the real world, you might say that a supply chain starts when you dig ore out of the ground and you dig your precious metals out of the ground. But once long ago, I was an astrophysicist, and I believe that if you want to talk about where your iron comes from, I say that iron comes from supernovae and the remains of dead stars, and took quite a long time to get into the earth before it was mined. So for the purposes of this talk, when I am talking about specifics of the software supply chain, I'm generally going to be looking at the raw materials as software packages. We will talk a little bit more about raw materials when we get to that stage of it and what I think those analogies are. But there are various different ways you can talk about the software supply chain, and that's the perspective I'm bringing. But a lot of this relates to all software supply chains and to all levels of the software supply chain. And if you want to talk about software supply chain security at some level, you do in fact need to think about all of these levels. But this level is the level that your average consumer of software probably can focus on the most easily. And not surprisingly, given the fact that you've gotten to the point where the government is talking about software bills of materials, corporations do consider it a best practice. And we've got 84% of corporations that are using software bills of materials today or plan to in the next year in some fashion. And that really stresses how important it is becoming to the industry. So if we've covered returns, and if we think that the industry is moving forward and that the software bill of materials and the things around it kind of cover this aspect of things, then the next question is production and transportation. And if we want to talk about production and transportation, we're talking about CI/CD. And honestly, there's a lot that can be said about CI/CD and the software supply chain. There's lots of ways that CI/CD can make the software supply chain less secure. There's lots of ways it can make it more secure. The main thing I'm going to point out is that if you're not worried about your supply chain in your automation, you've got a pretty big problem and you're going to have a hard time moving forward. And also, if you're not thinking about it, you need to be moving quickly. So my father is a software engineer who works on control systems. And when he retired, almost a decade ago now, but only a decade ago, because when I tell this story, you might think it was a lot longer ago than that. Shortly before he retired, he was walking out onto the floor where they build control systems before shipping them to customers, because control systems, in addition to having really critical software, also have hardware components. He saw something kind of strange. He saw these big cylinders out on the floor. And as he walked past them, he thought he recognized them, and he looked at them and realized that, yes, they were capacitors. And then he looked at what they were being connected to, and he realized that it looked an awful lot like a very, very old mainframe from back when, capacitors in mainframes looked like megafauna. And he went up to the foreman and he said, "What's this?" And the foreman said, "Well, it's an old computer." And my dad said, "Yes, I know. I'm old enough to remember, but why are we building one out of what looks to be new old stock?" And the foreman said, "Well, yes, it's a computer, but what you're really looking at is the only control system certified for nuclear power plants of a certain type in the United States. And we're working really hard to build this from new old stock because every single time we have to replace a single part, we have to file dozens of pages of paperwork for every time we change the manufacturer of a resistor. And God help us if we ever decide we need to take a bunch of transistors and combine them into one integrated circuit, because the amount of testing we would have to do at that point is pretty crazy. And I bring this up because I think there can be a temptation in software sometimes to say, if it ain't broke, don't fix it. And there can also be a temptation in any sort of design process when you're worried about the safety of things to document everything in triplicate and move very slowly. But compliance should not be dictating how you write your software. And in fact, if you let compliance slow you down, then you're basically just going to fall behind. In today's modern software world, we need to move fast. And if you don't have a way to do your compliance in a way that's compatible with your automation, in the long run, you're going to fail. Either you're going to fail in creating bad software that nobody is going to want to use because it is slow and unpleasant, or you're going to fail because you don't pay attention to the safety of your software and you're going to get sued because you failed in your compliance. There's lots of ways in the modern era to move fast and stay safe. There's good tools out there, good processes that you can adopt, and you should be looking at these when you're moving forward to secure a supply chain. And indeed, one of the major changes that has happened in the years since Heartbleed is the fact that organizations do start to have ways to do things like collect software bills of materials through their automation. So that while in Heartbleed, it took months in some cases for organizations to find all instances of OpenSSL, most organizations were able to find their instances of Log4j by using tooling relatively quickly. So another question that comes up in the supply chain is inventory, the artifact repository, and the central repositories. These are a critical part of the open source supply chain. I highlight here one of the more popular inventory systems, JFrog Artifactory. There are other repositories, Nexus, ProGet, depending on your ecosystem and language. But if you're not using some sort of inventory system, if you're not storing your binaries, then you probably have a resilience problem in your supply chain. Years ago, I might have had to explain why it's important to have a solid inventory of things, but this is 2022, and unfortunately, in the last couple of years, we've all learned just how disastrous it can be when there is a supply chain shock and we run out of things that we need in our daily lives. And the same is true when building software. Some years back, there was an incident where somebody removed a critical NPM package called leftpad from the npm.js central repository before the rules were changed to make that basically impossible. And pretty much all the builds involving npm in the world failed while people scrambled to try to figure out how to fix the problem. So it's a small thing. It's, not something that people tend to think about. It's something people tend to take for granted. But paying attention to where artifacts are stored is something that you need to be thinking about when you're thinking about your supply chain. And you should be thinking about, are your artifacts immutable? Are they local? And do you have checksum confirmation of them? Do you know basically where your artifacts came from? And if you do know where they came from, do you have a reasonable guarantee that they match the object that's actually in the repository that you think you pulled them from? This doesn't stop all forms of well poisoning, but it does at least make sure that you know where the well was. And then we get into sourcing. And as I said earlier, I think that sourcing is primarily about software packages in the modern era. Whether you're getting them from Maven Central or PyPy or npm.js, even if you're getting them from GitHub, do you know where you're getting your packages from? Do you know who built them? When we talk about the raw materials of software, we could be talking about commercial packages that you consume. There's still a lot of that in the software industry, while there's been a huge transition to open source as the main source of components. There's still plenty of components out there that are not technically open source or not at all open source and are commercially sourced. You could be talking about the tool chain. There are a lot of very fascinating and thankfully mostly theoretical attacks on compilers. And if your compiler, for example, is compromised, you've lost the entire game. There's really no way to recover from that except to start over again. And then you have the open source packages themselves. In this talk, we're primarily going to focus on those, but I do want to acknowledge that the other two are important. And note that both of the other two are also themselves generally related to and relying on the open source supply chain underneath. And that brings me back to our lovely XKCD, where we are talking about these open source projects that are being maintained by people that you probably don't spend a lot of time thinking about, except of course this is Upstream. So probably what I really mean is people like you. And hopefully you do spend a lot of time thinking about them. And if you don't, listen to more talks at Upstream, and hopefully you will be thinking more about them. But a lot of software developers in their day-to-day life, they just consume open source software packages and just kind of rely on them, and they're just there. And that's a bit of a problem, because these software maintainers are, for the most part, not getting anything for their work. 46% of them are getting paid nothing. 32% of them get some money, but generally not enough to really matter. And that's, a huge majority of maintainers. Now, there's great initiatives out there like the Linux Foundation Core Infrastructure Initiative, which tries to go out and identify key packages and get some funding to their maintainers. There's initiatives like OpenSSF that's trying to work with the open source community to improve the overall security of the supply chain. But this is actually a real problem. And some people present this purely in moral terms. There are billions, no, tens or hundreds of billions of market capitalization that are tied up in commercial software dependent on open source. And some of the key things that make this possible aren't properly funded, and people are working for free. And there is absolutely a social justice element to this. But there's actually a lot more than just a social justice element to this. It is also a real problem if you are an enterprise software developer and you are concerned about your supply chain. If you have no relationship with your suppliers, with these open source maintainers, anybody who talks about, sort of supply chain resilience is going to say that this is a problem. If you're not making sure that they're supported, that they're still going to be there in the future, then the resilience of your supply chain is in a lot of question. And absolutely, it should be. Nearly 60% of maintainers that we've surveyed have quit or are considering quitting. And it's no wonder. While maintaining open source code can be an amazing labor of love, it's also really stress producing. I love this quote from our maintainer survey, that being an open source maintainer is like living Goodwill Hunting in reverse. You start out as a respected genius and end up as a janitor who gets into fights. And I think anybody who's been involved in the open source community or done anything related to maintaining an open source package knows exactly where this maintainer was coming from. Very often, people think that a maintainer working for free owes people maintenance on their code. And, that can get to some very absurd levels. Back during the height of the Log4Shell situation, I saw a Twitter thread about a maintainer of an open source project who got a letter from the legal team of a major corporation asking him, as the maintainer of a project, to and as their vendor, to certify that he had looked through all of his dependencies and either determined that he was not using Log4j or that he had remediated the Log4Shell vulnerability. And he, with honestly a great deal of patience, explained to them that he was providing open source software, and that open source software is provided with no warranty, and that he was not a vendor of theirs because they were not paying him. They had no contractual relationship with him whatsoever, and that if they wanted him to do paperwork, they would need to actually have such a contractual relationship. And otherwise, their request was misplaced and going to be properly directed to dev null. And this brings up a good point. When we talk about problems in a software package, oftentimes we think about Log4Shell in terms of Log4j. And of course, the maintainers for Log4j did absolutely a heroic effort to get it remediated quickly, working nights and weekends so that all of the rest of us could have something to upgrade to and to fix the problem and make our software safe again. But it wasn't just about Log4j. The reason the Log4Shell vulnerability is such a big deal is because of all the software that depended on it, not just applications at the developed application level inside a corporation, but other software libraries depended on Log4j for their logging. And transitive dependencies are a problem. And if you don't have open source maintainers who have the time and the energy and the desire to keep those things up to date, you as an organization have a problem with your software supply chain if you're depending on one of those libraries. And if you think this is a problem and you're an open source maintainer and you somehow aren't aware of Tidelift, and I suspect that this far into Upstream, that probably isn't a problem that you have, you might want to come check us out as a maintainer to see about ways that we can potentially support you when you have to do some of these sort of maintenance tasks, and help people who rely on your software be confident in their ability to do so. And if you represent one of those large enterprises that relies on open source software, and you're wondering what you can do to make sure that your software packages are being maintained, maybe you also want to come talk to Tidelift from the other side. And at Tidelift, we believe that part of the answer to this problem is that software maintainers should be paid, right? And be paid enough money that it really has an impact on their lives. Money doesn't necessarily make you happy, but there's plenty of ways that money can reduce your stress, whether that be covering critical bills or whether that be letting you go on a vacation. And Tidelift doesn't just want to help open source maintainers with money. We want to help them with lots of the things that make it stress inducing. And I really do hope here at Upstream that you really put a lot of thought into the content that we're doing here about what we owe each other, or don't owe each other, as the case may be, as some people would argue, and how can we work together to make the open source community better, but also something that, you know, can be a realistic path forward, and one where people can be confident that critical packages are being maintained on the one hand, but on the other hand, not relying on people burning themselves out for no compensation. And really, this gets me to the last point when we talk about supply chains. And I thought this was really compelling. And it's really made me think a lot about planning. Do you have a plan around a software supply chain? And I'm willing to bet that if you work for a large enterprise that does something with physical goods, that they've put a lot more planning into their physical supply chain than they've ever really put into their software supply chain. If only because we're still all kind of new at this. And, you know, only 15% of organizations in our survey are extremely confident that their open source management practices are sufficient to their task. By the way, this is an awesome survey, and Chris Grams is giving a lightning talk today on it that you should catch either live or the recording of. And in general, when we look at year over year, organizations, large enterprises with more than 10,000 employees, they feel that the challenges of managing open source are increasing and not decreasing. And I would argue that this is a clear sign that as an industry, we are still coming up short when it comes to making plans around the software supply chain. What would a plan look like? Well, it would look like policy alignment between people. I was working with a customer recently of Tidelift's, and we went in to start talking to them about how they might set up their policies around open source management. And we ran into a really interesting thing where everybody who was working on the software day to day said that they were working to a policy around open source, was sure that there was one. But when we talked to the sort of the central people, the people that you would normally expect to have written such a policy, they were not aware of one. Needless to say, this was a misalignment that we had to do some work to address before we could be sure that everybody involved in the policy process was actually on the same page. It's about process. No tool is going to solve the problems of the software supply chain by itself. Not even the small parts of the software supply chain that any one company producing or consuming software has to worry about. You have to have tools and you have to have process to actually do something with those tools. Buying a tool and installing it somewhere and not connecting it to other processes that you have, not doing anything with the information it gives you, doesn't actually help. But that said, you do in fact need tools. If I learned anything back when we were working on Heartbleed many years ago, it was that trying to figure out what software you're using without a tool, without something that's tracking software bills of materials or able to do a component analysis or generally tracking what happens during your builds, is really, really challenging and quite unpleasant. On the other hand, if we look at a lot of organizations and their response to Log4j, well, it was still probably a lot more challenging than it should have been when they were trying to determine if they were vulnerable to Log4Shell. Their tools certainly sped it up in a lot of cases. You need to have all three of these things, and that's pretty much true for anything. People, process, and tools is the standard trifecta that people talk about when they talk about DevOps or DevSecOps. And in many ways, a plan is really just the heart of living a DevSecOps lifestyle. But I always want to call out that it's not just about, talking about DevSecOps or talking about shift left. It's a company-wide thing. It is about managing risk. It's about understanding those risks. It's about understanding the policies, understanding the business needs. For example, possibly you might be talking about in the software supply chain, not just security vulnerabilities, but you might be concerned about open source licenses. Are you doing the right thing when you're consuming your software, when you're using open source? Are you doing the right thing for the community? Are you following the rules that the maintainers set down for using their packages? And that's not something as simple as just following a tool. You actually have things you need to do that probably impact your business in various ways. And so I strongly encourage you, if you've managed to get to the end of this talk, to sit and think about your own plans around your software supply chain. And that applies if you're working at a large enterprise and consuming open source. But it also applies if you're a producer of open source and you're looking to provide open source tools that other people can rely on and be sure of. Have you thought about, what are the items in the OpenSSF scorecard and how can I make sure that I'm doing those things? Have you thought about where your dependencies come from? Everybody in the entire software industry needs to be thinking about these things and moving the bar forward. So in summary, we want to talk about the fact that the software supply chain really matters. That over the years, as people are starting to be more and more concerned about open source, we've made major forward progress by people adopting software bills of materials, I've heard people starting to talk about, yes, I'm going to insist that my vendors give me a software bill of materials for the software that they give me. In this case, I mean actual vendors, not open source maintainers, but people that are selling software. We've talked about the need to move fast and stay safe with DevSecOps, the need to have artifact repositories so that you know where your software came from and what it is. Pay the maintainers, because unpaid suppliers are always at risk of quitting. And if maintainers are being paid, it's not just that hopefully that will encourage them to keep doing the awesome work that they're doing, but also that will encourage them to think about things like succession plans when they want to stop maintaining a certain package for whatever life reason it is, or maybe they want to take a pause on that. And build a plan. If my example about a nuclear power plant told you nothing, it should tell you that software and the processes around software last a lot longer than we ever think it will. On the other hand, best practices are very definitely still evolving. Alignment inside the business is important, whether that be alignment required on what a policy is, or alignment required for the business to give the R&D team the breathing space they need to make their software supply chain secure. And thanks for coming to my talk. And I hope you found it interesting. I strongly encourage you, again, to check out the Open Source Software Supply Chain Survey Report. There is also an awesome lightning talk about it here at Upstream, or you can go out and look at the survey by following this QR code. And have a great day.